So good morning, everybody. So this is Ramesh Adhikari, and I'm from Humboldt State University, and I have a PhD in finance. So this year I chose to submit this talk to this conference, thinking that I can teach some finance to this computer and software engineers. I hope that this is going to be interesting for you guys. My goal is to show the use of Mathematica or Wolfram language in the investment analysis. So those of you guys who are very well versed in programming, how can you think of choosing investment field as your professional career or consulting for those kind of things? So what I would like to do here is mostly I would like to talk and show the application of this Wolfram language for analysis of investment. That's what I'm trying to do here. So I have a broad outline here. So the cover is very wide here. So I teach finance courses, and what I did for this talk was I pulled major computational part of my course and put this all together. So this is a kind of summary of 3 courses I teach, both at the undergraduate level and the graduate level. So I will be very quick because each topic needs a very detailed discussion, but since the goal is just to introduce you the new field to you guys, so I would be very brief and I will be showing just the application part. So why I chose this Wolfram, and I think we all have our own story, but for me, I went through different programming language, and when I came to this Wolfram, the first point made very good sense to me. And actually, I am writing a book based on what I have here. So that book has built-in text, code, and everything I do in that text is collecting data from online sources and producing result within the text. So traditionally, we have a text, and then when you need to do something, you have to download the data and put on your computer and upload it and do analysis, right? So for this, the kind of text that I have envisioned and that I'm working for is mostly it goes and pulls the data from different sources and then computes and does the analysis that you said to do and produces the result. So then you can use for your benefit. So the next, what I'm going to do is I will go over broad set of applications that I think, and again, we all are the victims of our own knowledge limitations. If I say something that doesn't make sense to you, please excuse me. Again, the choice of the application is purely based on my own experience, but I think Wolfram can go way beyond than what I have presented here. So the first thing first, would be to access the data. So there are different ways you can get the data on this, and if you have a professional version, I think they have integrated the data import from Bloomberg and Reuters, but mostly this is free kind of like data sources. So first, what I see or what I show here is how can you get data for your data analysis and visualization. So I have a few examples here. So one would be simply using the built-in functions to download the company fundamental data and then plot this and make a databases. So that would be the first application, because without data, so we can go nowhere. So I have here shown some examples. By the way, these all are the functions that I wrote based on the features that I have available in the Mathematica. So these are all the functions, and what I'm going to do when I'm done, actually, I will upload all the functions that I have written and make available to the users. So that's the goal. So here I have the data on Apple stock, and I have return on asset, return on equity, and revenue growth, the first one, and then the second one. What I would like to do is I compare the performance of different companies and see how these guys do. So what is the beauty of this Wolfram language, or the book that I'm talking about, is next time when people would like to reproduce the result, all they have to go is change the ticker symbol and then they change the date and rerun the program, and then it just gives you the result. So that's the beauty of, I think, building a software system that can go and pull the data from online sources and produce the result. And here's a data retrieval from Quandl. Quandl is, I think, building a huge data library, and then you can pull the data from Quandl and do all kind of analysis. Then I also have here data from Federal Reserve. So if you know what kind of data you need, you just need the ticker symbol. So all you have to do is put the ticker symbol on the top and then change the date, and then you plot it, and then it gives you. And also what we can do is, I have done this only for one stock, but you can download the huge amount of data and make the database of stocks or anything that you're interested, and then using the SQL query language, you can do all kind of analysis. So that's why the first focus of this Wolfram is mostly how to retrieve data. So that's the one thing. The second that I would like to talk very briefly, and I think for many of you this might seem very foreign, valuation, business valuation. So oftentimes when we think of investment, valuing the financial asset is the first thing that we should understand. Otherwise, you don't know what you are doing, right? So therefore, these examples focus on how can you value financial assets. But this is purely one example, but Wolfram can be used in a wide varieties of valuation areas, from startup valuation to the valuation of well-established company to valuation of a stock or valuation of bonds and all kind of things. So, and not only on the top of that, we can also use this Wolfram language for capital budgeting, investing. When businesses make huge investment, how can we use Wolfram language in order to make this capital investment decision? So this is the second area of application of Wolfram finance. So third area, okay, I would like to go and talk about the performance analysis of stocks. If it is individual stock, how would you do some analysis? So here I have written functions. All you have to do is just change the ticker symbol that you would like to analyze, and then change the date, and then look at the performance. And I have different kind of graphs: price over time, normalized price over time, and I think we even don't have time to go over each of this graph. I would just show the broad application that I have chosen here. And then we do have some descriptive statistics that we can compute in a one-line code. And if you are looking at multiple stocks, then you can put those multiple stocks and then make a graph. And this graph is, one is I have the normalized price. Basically that tells you if you had invested $1 back in 2000 on each of these stocks, how much would that be today? That kind of things. That's a normalized graph. And then next is the cumulative return. And I can also calculate performance of these stocks. So why I think Wolfram is very good, if anybody would like to understand about finance, one has to understand psychology, one has to understand economics theory, and one has to understand also the finance theory. But that's not enough to learn finance. One has to know mathematical, statistical theory, as well as computer programming. So Mathematica provides some tool that can help you on the mathematics and statistics and the programming side of investment analysis. That's why I think just one line of code, and like a lot of measures that have reported can be computed with built-in functions, and some other performance analysis you can combine some other built-in function and then you can compute them. So therefore, this Wolfram language becomes very powerful when it comes to performance analysis of stocks. So the next, I would like to show you the factor models. which means this is the emerging literature, people talking about this factor modeling and factor investing, which basically means we all want to invest in the stock, but we don't know where to invest, right? So the factor model tries to explain what factors should you look at about the company if you would like to invest and make money over time. So what I have done here is there are different kinds of factor models, but one of the most popular factor model is 5-factor models. So what I do here is all this factor data is available online. So you go and pull those factor data, and then you have the stock price you can pull from your financial data sources, and then merge these two, and then run a regression and give you the result. So this is just an example, but if you have, let's say, if you have a 500 stocks, then you can run 500 all kind of regressions, and then that gives you the factor loadings, and each of these factor loadings has its own meaning, and if you know how to interpret that meaning, then you can build all kind of portfolio that you are interested in based on those factors. So this is another application of Wolfram language that I am aware of. And the third, I think another one is, how we can evaluate the performance of investment. It could be mostly the performance of portfolio. If you have invested in a multiple stocks and you have a portfolio, what measures are you going to use to evaluate the performance of your portfolio? So this one line of code can compute all these measures. They are very standard measures. They are used to evaluate the performance of portfolios. So anybody new to this field can come and change the ticker symbol. These are the mutual fund that I'm looking at, which mutual funds are doing how. So anybody interested in what they have to do is simply change the ticker symbol, and I'm comparing the performance of these 3 mutual funds with this SPY. SPY is the ETF that tracks the S&P 500. So that's another area of, again, as I said, this is very comprehensive. We don't have time what each of these numbers means. But I will make this slide available and then some interpretation of the number later. So another area of is technical analysis. When it comes to technical analysis, Wolfram language is very well versed. It has a lot of function, but one of the things that I'm interested in is pattern recognition, the stock movement and how we can find the overbought and oversold looking at the historical price. So the pattern recognition, and actually I think we all are familiar that Wolfram is very good on pattern recognition, but I haven't seen anybody done that work using Wolfram language, and I think there's a field and what we can work on pattern recognition on the stock prices using Wolfram language, and I think there can be some online tool we can develop out of it. That's another area where we can think of using Wolfram language. Here I was trying to find out the buying and selling signal on this Roku stock when I was looking at this data last time. Another area would be bond and derivatives, bond market analysis and derivative product. We can use there too. So here I have manipulate, and we can change the different parameters of the options and change how the price of call and put would change. And binomial model, some of you may be familiar because this is a very popular model. But one of the things that I am interested here is I have written a function. What it does is it pulls the data of a real company and then computes its call and put price and then gives you the theoretical value. It's important, and you can always compare the performance of any stock in a theoretical value versus what the value observed. And if there is some discrepancy, why is that? So that's another area of finance that I have looked at. Another one would be linear programming. I think, again, this is a giant problem. I converted a financial problem into a mathematical problem, And when we want to solve this kind of linear programming using Mathematica, we can easily do like make a functions and then solve it in one line. I have done this in two ways. So those kind of complex problem can be used or can be solved using Wolfram. And another area would be, okay, mean variance optimization under uncertainty. I think that's the area emerging. Oftentimes we do mean variance, like when we invest, don't put all the eggs in one basket kind of principle, right? So you have to look at the risk and return portion and then try to maximize your risk return ratio. And oftentimes we look at the one set of data and we maximize, and based on that we make investment decision. But whereas this one, we assume data is uncertain. We have thousands of realization of data, and when you have data uncertainty, how would you make investment decisions? So that's what I look at here, and I have written some robust tendency portfolio, some functions. All you have to do is look at the stock that you want to put in your portfolio and how many data you want to regenerate, and based on your simulations and bootstrapping, however you like to generate the data, and then it gives you the optimal weights. So that's another area that I think has a real value. Another would be mean conditional value at risk optimization, where you measure risk not by the standard deviation but value at risk. If you are measuring your risk using the value at risk, and how can you optimize your portfolio? That's another area of application of Wolfram language. And here's a simulation and bootstrapping, and I think Wolfram has a lot of built-in functions that can support simulation, bootstrapping, and finance has wealth of application, especially when it comes to risk management and data analytics. So we can also use there. And here I just run bootstrapping and then look at the different descriptive stat of that bootstrap data, and then also look at the data on the histogram and look at the different property of the data. That's another area that I think this is there's a well application of Wolfram language. And here's a time series part. Also Wolfram has a lot of time series functions, but it doesn't have a lot, but what I think is it provides a lot of tools that you can take to the next level. So mostly the Wolfram has a univariate time series analysis functions, but you can always extend it to a multivariate time series analysis as well. And here I have some examples of looking at this, what kind of model would fit to the data, and looking at the correlation, autocorrelations, and based on all the analysis that I have done, you can also forecast the future value of the series that you are looking at. How accurate that is going to be depends on the expertise as well as the assumption that you make on your forecast. And here is one interesting curve that I have been looking at, and it is grabbing attention, whether they're going to be a recession very soon, right? So I look at the yield curve and the recession, and I looked at the data for the last so many years, and you see this is the spike. Every time you see the spikes, and after that some time you see the recession. And here is the one, I think, so I'm not, okay, so it doesn't show here, but if I can show you guys, was that? Yeah, so yes, it is just like that. And this is happening. So you see every time this volatility in the yield curve here, and then after some time we have observed in most of the time recession. So right now we are seeing similar instance, and whether the recession will come or not. So anyway, the point I'm making here is, yes, we can do those kind of analysis also using the Wolfram language. And This is the last section, and AI and machine learning. I think many of you guys are more expert than I am. But I would like to emphasize here that we've been talking about this a lot, and most of these companies focus on traditional goal that finance professors or the business people have been teaching, that is wealth maximization, shareholder wealth maximization. But when you guys work on this AI and machine learning, I would like to emphasize on broader set of goal than wealth maximization or money making. We have enough money than we need, and based on the the capitalist idea that we have practiced over 400 years, now the wealth is being concentrated in the hands of few people, and then more and more people are left behind, right? So when you think of machine learning and AI, I would definitely encourage you guys to think outside the box, not just focus on manipulating data and then making money. Think about the environment and the society, and then the equity part. What is it going to do to the people who live in the society? What it is going to do to the environment, and what it is going to do the planet as a whole. So therefore, when I think of this AI and machine learning, I would like to encourage people to think in a multiple dimension rather than just focus on the data and how the data can be mined and then make money. So we should make a broader objective, broader goal of AI and machine learning than just making money. That's the point I would like to make. And finally, as I said, I think I will make this all available. So anybody interested learning about finance using Wolfram language and take this to a next level, I think most of you guys are programmers, so you can take everything that I have put here and you can take to the next level and then show the people that yes, Wolfram is very powerful, and then we can use in the investment analysis. And I was surprised when I came to know that Wolfram is so powerful, but if you see how many people use in finance industry, not very many people use it. And that surprised me. That's why I'm really interested, because it has so much built-in knowledge and power, but we are not using it. And especially since I'm a faculty, and when I go and teach students, they don't have math background, strong math background. Like the competition is so intense, we are making this business education easier. They come to the class without much mathematics background, statistical background, and no computer programming at all. But if we use Wolfram, I think Wolfram can enhance those skills, help our students and the people to learn about finance concept using already built-in knowledge. So that's all I have, and I think I'm on time. So if you guys have any questions, feel free. But again, this is more overview than anything specific.